Hello, today I'd like to explain something regarding the SIKA EC7 process multimeter. The process multimeter is a combination of an DMM, that means a digital multimeter, with an multifunction process calibrator. So that means with this device we can even generate some signals. And the setup of the device is we have a large display, different kinds of operating button, and a selector switch to select the desired function. Today I like to explain something regarding generating, so that means sourcing an milliamp value into a loop by using the internal loop supply. So that means we will use an internal power supply of the device to power up a loop and generate an milliamp signal into the loop. That's the setup. So that means I like to power on the device, and I select the function with the rotary switch. Then I have different information on the display. So it's milliamp in DC, of course, because we have 4 to 20 milliamps normally. And now we have 0 milliamp, and that means minus 25% below 4 milliamp. Yeah? So, and then the loop power is on and we source, that means we generate a signal, and currently the function is switched off. I like to show how the internal power supply works. That means I connect the terminal to the loop, and to measure the loop voltage, I connect a digital multimeter to these two terminals. And then I switch on my loop power, and then you can see on this display the voltage is increasing in the range of 24 volt. So after a while we have the full voltage to power the loop. So you see we have a voltage internal source up to 25.4 volts. So then I disconnect my DMM, switch over to milliamps, 20 milliamp range, and use this terminal for the loop supply to power up the loop. And here the closed loop, the milliamp, is going back into the device. So I have different possibilities to generate my desired milliamp into the loop. I have a selector switch, left side, right side, and that means I can change the position of the cursor. I go in this direction, and then I increase the value. So now I source into the loop 1 milliamp, and that means this is milliamp. 0.96 is indicated on my amp meter, and so that means I can change over the position and increase, and now we see 11 on the instrument, and on my amp meter I see 10.7 milliamps into the loop. I can switch off, and then I see 0. I can switch on, and then I can see again the 11 milliamps. And in the auxiliary display I see currently the starting point is 4 milliamps. I go down to 4 milliamps, for example. I go down to 4 milliamps and then we come to, sorry, to 0. Yeah. So the auxiliary display shows the percentage in steps of 4 milliamps. So 4 milliamp is 0%. Good. So an additional function I like to show is the steps in 25% or 100%. This is another functionality. I switch off. I use this function. I operate and activate 25%. In the display you see 25%. I switch on. So now I have 4 milliamps. And if I increase now, then I will increase in steps of 25%. So that means 8 milliamp, 50% is 12, 16% is 75, 20% is 100%. Yeah, and above 100 it will not increase. I can decrease manual by using the operating buttons and then going back 4 milliamps to 0, and I cannot go below the 0. I switch off and then I see here no current is in the loop. I select 100%. I switch on. I see 4 milliamps. I see 4 milliamps in the loop. And now I increase in steps of 100. So that means I switch immediately over to 20 milliamp. Go up, go down, go up, go down in 100% steps. So that means the milliamp in the loop is changing from 4 to 20 milliamps, from 0 to 100%. Okay, I switch off my loop and then I go to a next function, and we have the possibility for ramp and step function. So this is a ramp, increasing, decreasing ramp, and steps, increasing, decreasing. That means I select this function and then I see the ramp function with this symbol and an S. So that means this is the slow version of the ramp function. That means increasing 4 to 20 milliamp takes approximately 30 seconds, and this is done complete automatically. So that means the loop is switched off. I switch on and I operate this button. That's the start button. I start, and then you see automatically the current into the loop is increasing, and the loop current is also increasing. So it goes up to 20 milliamp in a time of approximately 30 seconds. And if we reach 20 milliamp, then it goes down again within 30 seconds to 4 milliamp. So now it's decreasing. I stop this, switch off my loop power, my loop current, so it's 0. I select the next function. It's again an ramp, but now it's with fast. I put on my current. I start the automatic increase of the value, and now it takes approximately 15 seconds from 4 milliamps to 20 milliamps. And then if we reach 20 milliamps, it goes down again, so increasing and decreasing and that the process is running. You see on the change of the values, and in addition you have the sign of run. I stop, I switch off, and I go to the next function, and this is the step function. And again we start at 4 milliamps, and it will increase in steps of 25%. That means in steps of 4 milliamps. I switch on, so that means in my loop I have the 4 milliamps, and then I start, and it takes approximately 5 seconds to increase the value of the milliamp in steps of 25%. And if we reach 20 milliamp, then it will decrease. So we have the 20, and then it goes down. Next step is 16, and you see the process is running. I can stop it, and then I change over to the normal mode. Yeah, I switch off the current, and at least that's what to explain regarding generate a milliamp with internal power supply of the instrument with these two connection terminals. That's it.